Welcome to another video on smart architectural programming, and in this video we'll be solving the binary tree maximum path sum problem from the LeetCode 975 list
delve
of
further
questions
into
that
this
most
problem,
commonly appear in coding
I would
interviews.
like you to like and subscribe our channel if you got any value from our video, and let us know in the comments if you feel there's any question, query or problem that you want us to solve. Without further ado, let's dive deep into this problem. So in this problem, what we need to understand is that given a root of a binary tree, we want to find a single path, single non-empty path through which we get the maximum sum of the numbers within the node of the binary tree. What do I mean by that? So when we talk about a single path means that if we move from, let's say, 15 over here, minus 15 over here, right, and then move from here to here, right, in a straight line, at every node we can only move one direction, right? So if this entire path, let me use a different color here. So this entire path is a single path that we can say that, this is a single path and this is what the question is asking. But potentially, if we let me use a different color, if this dark green color, we, after including this, we also include this 5, that's incorrect, because under the single path at every node we can only move one direction. So if we are at this 20, either we can move downwards or either we can move to the left, right? We can't move multiple times. So given that understanding that we have regarding pathways, let me actually move this a little bit to the right so it's more clearer. So given that understanding that we developed, the next question is how finding the maximum number or maximum sum in a single pathway, right? How do we go about doing that? So the most efficient method is the depth for search algorithm that we talk about in binary trees. Basically, that's the best and the most efficient, which would give us a time complexity and a space complexity of O of n. Basically, what do we mean by time complexity and space complexity? Basically is that for n represents the number of nodes in the time complexity, and space complexity is basically the height of the tree, right? So that is the most ideal position to be in. So basically, n here is the number of nodes, and for space complexity, n is basically the height of the tree. So given that understanding, let's focus on this question again. So how do we go about finding the most efficient pathway in this? So potentially what we could do is we could basically, we have minus 15 here, right? So that we don't need to include anywhere because that's going to come in every pathway. So after that, we can, let's say, use a different color here. We move to the left side, right? That's the first one side we move. And we calculate, like, if we are at this point in the node, what is the maximum number that could be added here? That's 10, right? So either way, if we move to this domain, 10 is going to be added to our root number, right? But there's no left and right, so we can presume that that is all we need to do, right? But if we move to the other side, which is the right side, we know the maximum number here is 20, but we don't need to stop here, right? Because that's one part, right? Then we go and look at the left and the right sides of this particular node, right? Which is on the left, we go and we see, like, yeah, it's 15, the maximum number, right? And on the right, if we go, the maximum number is 5, right? Then we don't have left and right on this side, so we go to the left of this node again, and we have minus 5 here. So basically, another aspect to this question, what you need to remember, we start our movement not from the root node, right? We test our movement from the bottom. So we move from down to the top, right? Our movement direction is from the bottom of the tree to the top, right? So given that understanding we have, how do we go about doing it, right? So first of all, we need to do if we have two options, like, if we have two pathway options, like between 15 and 5, we apply the max function, which basically tells us exactly which pathway we need to undertake, the maximum of these two, right? And potentially, as we can see in this particular portion here as negative, you might be assuming that in the max function it's just 15 and 5, right? Let me go back to the previous color. So potentially here the max function would be 15 and 5, right? I'll leave a space here for basically the point we need to make further. So yeah, so given this is the max function here, right? So at the bottom though, it's slightly different. So here our max function is going to be, there's no value here, but we still run a max function here. Why? Because the value is negative 5, right? So that would reduce our total value. So which means we can't, presumably you'll believe that we'll just have to do it, but that's an option. We probably don't have to do it, right? For that, it would be -5 as the first value. The max function would run -5 and 0, right? Whichever is bigger, which is 0, it would make the choice. And with the 0 choice, we understand we don't need to move further. Similarly here, the max function other than 15 and 5, 0 would also be an option. So we'll be running zeros in every max function in the decision making areas to see if we increase our value. If 0 is the maximum value, then we know going further down would reduce our value, so we don't need to go down further in the tree. So based on that understanding, we move from the bottom, right? So what is the most efficient pathway in this particular channel, right? So let's go from the bottom, or rather from the top. It would be better to understand that if we go from the top side. So we have -15 at the top, right? Let me use a different color here. So -15 is at the top, right? So that's our first value. So then we have the choice between 10 and 20. 20 is next. So we add 20 here, right? 20 is next. And then we have a choice between 15 and 5. Then we add 15 over here. And then our choice is between -5 and 0. So we don't move further. So that's 35 minus 15. We just got, let me use red color here. That's a little more appropriate. These two cancel each other out. So our best pathway is 20 in this route, right? And what is our best pathway here? This is our best pathway in this particular question, right? So this is the pathway, the best pathway for this 15, 20, 15. So that is our understanding for this particular problem. So now we're going to write our code, go over our code, which has already been written, and explain this problem as we move through it. So basically our approach in this particular problem is quite simple, right? So first we need to calculate the maximum path sum that passes through each node and update a global variable to store the over maximum path sum. So to do that, we define a helper function that recursively computes the maximum gain from the left and right subtrees. For the current node, calculate the path sum that includes a node both at left and right children. Update the global maximum path sum if the path sum is greater than the current global maximum, and return the maximum gain from that can be achieved from the current node. Then the base case is when the node is none and the return is 0, and we return the global maximum path sum basically. So the recursive function, basically max gain, computes the maximum path sum that can contribute from each subtree. Only non-negative gains are considered using max function, and there's 0 as well. Calculates the path sum that includes the current node and both its subtrees. Global maximum update at each node, we consider whether including both subtrees with the current node gives us a better path sum than the previous recorded one, and then we return to the parent. Basically, using recursion, we continue to return to the maximum gain from the current node to its parent. With that understanding, as you can see, this particular code base here, we were able to solve this problem, right? Let's run this code. Both of the cases were accepted, so let's submit this problem. The problem was successfully submitted, and that's how you solve the binary tree maximum path sum problem on the LeetCode blind 75 list of problems that most commonly appear in coding interviews. With that, I'm going to sign off from this video and see you in our next video. Thank you.